Artificial gravity has been a topic of interest and research for many years, particularly in the context of long-duration space missions. The human body is adapted to life on Earth, where gravity provides a constant force that affects our physiology in many ways. In the microgravity environment of space, however, the absence of gravity can cause a variety of health problems, such as muscle and bone loss, fluid shifts, and changes in the cardiovascular system. To counteract these effects, scientists and engineers have explored various methods of creating artificial gravity in space. Here are 5 proposed ideas about artificial gravity and why they were not successful just yet. Welcome to our channel. Please subscribe if you have not already done so, and let us get curious together. Wernher von Braun. In the 1950s, von Braun proposed the idea of a rotating space station as a way to create artificial gravity. His concept involved a wheel-shaped structure that would spin around a central hub, producing a centrifugal force that would simulate the effects of gravity. The concept was later developed into the design for the International Space Station, ISS, which has a centrifuge module for conducting experiments on the effects of artificial gravity. However, the centrifuge is not used for creating sustained artificial gravity for the astronauts on board, as it would require a much larger and more complex structure to generate a suitable level of gravity. Gerard O'Neill. In the 1970s, O'Neill proposed the concept of a space colony, a large, rotating habitat that would be capable of supporting thousands of people in space. The colony would be built from materials mined from the Moon or asteroids and would spin around its axis to create artificial gravity. However, the concept was not feasible due to the high cost and technical challenges involved in building such a large structure in space. Konstantin Tsiolkovsky. In the early 20th century, Tsiolkovsky proposed the idea of a gravity train, a long, cylindrical spacecraft that would rotate around its axis to create artificial gravity. The spacecraft would travel along a track that was oriented perpendicular to the direction of the spin, allowing the passengers to experience a constant level of artificial gravity. However, the concept was never realized due to technical challenges and the impracticality of building such a long spacecraft. Robert Forward. In the 1980s, Forward proposed the idea of a gravity lens, a device that would use the gravitational lensing effect of a massive object to create a focused beam of artificial gravity. The device would consist of 2 massive objects that were positioned in such a way as to bend the path of light and create a gravitational lens that could be used to focus a beam of artificial gravity on a spacecraft. However, the concept was not feasible due to the technical challenges involved in building and positioning the massive objects required for the device. Frank Vertosik Jr. In the 1990s, Vertosik proposed the idea of a gravity bed, a device that would create a localized field of artificial gravity around the bed of an astronaut. The device would use a combination of magnetic and gravitational fields to create a stable environment that would allow the astronaut to sleep and rest in a more natural position. However, the concept was not successful due to technical challenges in creating a stable field of artificial gravity and the limited applications of the device. Despite these challenges, there is ongoing research into artificial gravity, and several new ideas have been proposed in recent years. These include concepts such as spinning spacecraft. The concept of using spinning spacecraft to generate artificial gravity has been around for over a century. The first published reference to the idea was in a science fiction story by H.G. Wells called The First Men in the Moon, which was published in 1901. However, the concept was not tested until much later. 1. One of the first experiments with a rotating spacecraft was conducted by the Soviet Union in 1961, using the Korabl Sputnik 4 spacecraft. The spacecraft was equipped with a 2.4-meter diameter centrifuge that could spin up to 10 revolutions per minute, generating a centrifugal force of up to 0.15 grams. This was followed by other experiments, including NASA's Skylab space station in the 1970s, which had a large rotating section that could generate up to 1 gram of artificial gravity. Magnetic fields. The concept of using magnetic fields to generate artificial gravity was first proposed by Russian scientist Konstantin Tsiolkovsky in the early 20th century. However, the idea was not tested until much later. In the 1990s, NASA conducted a series of experiments called the Maglev project, which tested the use of magnetic levitation for microgravity research. The project included a small spacecraft that was suspended in midair using a powerful magnetic field. This allowed researchers to study the effects of low-gravity environments on various materials and organisms. Tethers. The concept of using tethers to generate artificial gravity was first proposed by Robert L. Forward, an American physicist and science fiction author, in the 1960s. Forward's idea was to use a long, thin cable that would be attached to a spacecraft and spun around in a circle, creating a centrifugal force that would simulate gravity. The concept was tested in 1996 by the Japanese Space Agency, JAXA, using a tethered satellite called the Tethered Satellite System, TSS. The TSS was deployed from the Space Shuttle and used a 20-kilometer-long tether to generate a small amount of artificial gravity. Variable gravity habitats. The concept of using variable gravity habitats was first proposed in the 1950s by American scientist Wernher von Braun. Von Braun suggested that a spacecraft could be designed with a rotating section that could be adjusted to generate different levels of centrifugal force, simulating different levels of gravity. The concept was tested in the 1980s by NASA's Space Station Freedom program, which included plans for a large rotating section that could simulate Earth's gravity. However, the Space Station Freedom program was later cancelled, and the concept has not been tested since. Artificial gravity chambers. The concept of using artificial gravity chambers for short-term exposure to artificial gravity has been around for decades. One of the first experiments with this concept was conducted by NASA in 1966, using a small, spinning chamber called the Astronaut Fitness Project. The project was designed to study the effects of artificial gravity on human health and fitness during spaceflight. Since then, other experiments have been conducted using similar devices, including the short-arm human centrifuge at NASA's Johnson Space Center, which has been used for training and research purposes. Meanwhile, private space companies like SpaceX and Blue Origin are focused on developing reusable spacecraft and rockets, with the goal of enabling cheaper and more frequent access to space. While these companies have not yet publicly announced plans to explore artificial gravity, it's possible that they may do so in the future as space tourism and other commercial space activities become more common. One of the most promising areas of research for artificial gravity is the concept of spinning spacecraft. A spacecraft that rotates around its axis generates a centrifugal force that creates a sense of gravity inside the spacecraft. This concept has been proposed for various missions, including a proposed Mars mission by NASA in the 2030s and a proposed lunar base by the European Space Agency. One example of current research into spinning spacecraft is the Nautilus X project, which is being developed by NASA's Johnson Space Center. The Nautilus X is a modular spacecraft concept that would be capable of supporting long-duration missions to deep space destinations such as Mars. The spacecraft would feature a centrifuge module that could be used to create artificial gravity for the crew during the journey. Another research project is the MagBeam concept, which is being developed by the Gateway Foundation. The concept involves using a magnetic field to create a beam of artificial gravity that could be used to propel spacecraft through space. The concept is still in the early stages of development, but it has the potential to revolutionize space travel by allowing spacecraft to travel faster and more efficiently than current propulsion methods. Overall, while the challenges of creating artificial gravity in space are significant, there are many promising concepts and research projects underway. As humans continue to explore and colonize space, artificial gravity will be an important technology for ensuring the health and well-being of astronauts and enabling long-duration missions to deep space destinations. It is difficult to predict with certainty whether or not we will be able to successfully create artificial gravity in space, as there are still many technical and engineering challenges to overcome. However, given the amount of research and development that is currently underway in this area, it seems likely that we will continue to make progress and eventually find a way to create artificial gravity. As mentioned earlier, there are already promising concepts and technologies being developed, such as spinning spacecraft and magnetic fields, that could potentially be used to generate artificial gravity. While there have been some setbacks and challenges along the way, the fact that researchers are continuing to explore and develop these technologies suggests that there is a strong desire and motivation to solve this problem. It is worth noting that even if we are able to create artificial gravity in space, it may not be a perfect solution. For example, the gravitational force generated by spinning spacecraft may not be exactly the same as the gravity experienced on Earth, and there may be other potential side effects and drawbacks to consider. However, even a partial or imperfect solution could still have significant benefits for human space exploration. Thank you for watching. Please subscribe to our channel and leave us a like.